Hi, I am Prince Yadav and I want to highlight some major problems with the EV vehicle. Firstly, humans had made a wonderful journey from loud gas guzzling internal combustion engine to super quiet electric vehicles. Now these electric vehicles get power from big electric motors, and electric motors we use is driven by the battery. But this EV concept has many limitations. The main problems are associated with the battery. The battery is very huge and bulky. On an average, a battery can increase up to 30% of the overall weight of the car compared to equivalent combustion engine. This results in more friction and decreased efficiency of the car. This battery is made up of system of small cells. Hence, this battery requires an extensive cooling system for each individual cell. When the vehicle is in continuous use, there is a huge pressure on the cooling system, which results in excessive heating of the battery and then explosion. The battery we use is made from lithium plus ions. The extraction process of lithium is very resource demanding, and we specifically use a lot of water in this process. If we continuously begin to use lithium, it would be out of stock in 2026. One of the main problem is charging time of the vehicle. Most of the owners charge their vehicle at their home, which is very slow. Even at the charging centers, the charging is very slow. Even the fastest of the fastest charger currently available is 800 volt DC fast charger, which is very costly and dangerous too. To solve all this problem, we come up with a project named Magnetic Induction Vehicle or MIV. This will solve all the problems mentioned. Now our friend Rahul will tell you about some basic concept of our project.
So hello everyone, my name is Rahul. Now I am going to explain the concepts used in our model and the working of our model. So let's begin. The main concept used in our model is of electromagnetic induction. We have primarily took the advantage of mutual inductance between two circuits. That is, there is a primary circuit connected to a primary coil which is below the root of our model. This primary circuit is given a DC supply which is converted to AC supply by it, and this causes an alternating current in the primary coil. Because of this alternating current, a changing magnetic field is produced around the primary coil, and hence a changing magnetic flux will be produced around the secondary coil. So, by Lenz's law, a current will be induced so as to oppose the effect of the changing magnetic flux around the secondary coil. Obviously, this current will also be alternating in nature, which is supplied to the secondary circuit where it is converted back into direct current by the use of rectifiers. Now, this direct current will be fed to the motor of the car, and now the car can move forward. But the main problem faced here was that there should be multiple coils below the road for the continuous motion of the car. This implied that there should be multiple primary circuits to power each of these coils. This would have been a very hectic and an expensive task. But the problem was very effectively solved by our team by making use of IR sensors. There is a single primary circuit, the main one, which is connected to all the multiple coils which were further connected to these IR sensors. When the car crosses a particular IR sensor, it switches the primary circuit to its corresponding coil which is below the car, and the car can now move forward. This ensures the continuous motion of the car, and the problem is very effectively solved at a very affordable cost. Thank you.
Welcome to the circuit explanation part of this G101 project of Ropar. This is Magnetic Induction Vehicle project, and my name is Revanth from Electrical Engineering BTech first year. Now I am going to explain you the circuit performance. That means how does the circuit work in order to produce the output of the project that you will be seeing in the demonstration part. So first of all, the whole circuit is divided into two parts. The first being the primary circuit and the second is the secondary circuit. If you see, this part is the primary circuit and this is the secondary circuit. So first of all, when you see about primary circuit and secondary circuit, the division between the primary and secondary circuit is the road. That means the primary circuit will lie below the road and the secondary circuit will lie above the road, that is in the MIV, the magnetic induction vehicle. So when we want to see about each and every element of the circuit explanation, I will be taking up each and every element. First, this is the 5 volts DC supply. That means firstly the DC supply is fed as an input in the primary circuit. Then afterwards, we need to understand about what is the working of these MOSFETs that are visible here. First of all, MOSFET means metal oxide semiconductor field effect transistor. So let me give a brief introduction about how does a MOSFET is working. Here MOSFET is used as a switch that is in the active state. So first of all, when we see the MOSFET, here in our project we have taken an N-channel MOSFET, whose specification is IRFZ44N type MOSFET is taken. Here in this MOSFET, this part is known as the source, this part is drain, and the blue bottom one is known as the substrate, and the top one, which is shown here as having a certain dielectric material above which, is known as a gate. So actually a voltage is applied across the source and the gate, which is known as gate source voltage, VGS, and depending upon the VGS, the electrons transfer from the source to the drain happens, and depending upon which the current from the drain to the source will go. So if the voltage across the gate and the source is above a threshold value, then the switch, that means the MOSFET in switch state, is said to be in on state. If the current is not going through this channel that is seen here between the source and the drain, then the MOSFET is said to be in off state. So this voltage which is applied across the source and the gate will decide whether the MOSFET is in on state or the MOSFET is in off state. So who will decide the voltage across MOSFET is nothing but this LC oscillating circuit. This LC oscillator circuit contains two inductors set in parallel, as well as a capacitor, as well as the inductor of the primary circuit. The LC oscillations of this will decide the switching of the two MOSFETs alternatively, and due to switching of these MOSFETs alternatively will lead to the different directions in the primary coil. Initially, for example, this MOSFET is in on position, then the current flowing through this MOSFET will be in this direction, and whenever this MOSFET is in on state, the current flowing will be in this direction. That means the value is remaining constant, but the direction is changing, so that an AC current is generated, that is an AC field is generated at this primary coil. So this LC oscillator circuit will act as a driver, whereas these MOSFETs are switched. As the MOSFETs are switched at a very faster rate, the frequency that is produced of the AC field that is produced in the primary circuit here is of the order of 200 plus kilohertz of frequency is produced in our circuit. Next, if we observe at these diodes which are there, these are known as the body diodes. So what does these body diodes do means, these body diodes are kept in order to solve a problem in the circuit. So when we observe, for example, assume that these two MOSFETs are in off state. That means no current is allowed to pass through the MOSFET. But until at the time at which these two MOSFETs came into off state, until which the current is flowing in the inductor. So whenever they are set to off state, the current will become zero in them, but current in the inductor can't be zero at a very quick time. It will go on through an exponential order. So in order to satisfy and maintain the continuity for the current, these two body diagonals are attached across the body of these MOSFETs, and the work of these things is to maintain the continuity. And when we see about these resistors are there to pass on less currents to MOSFET as well as to the diodes that are attached here. That means to maintain the current values through certain elements of the circuit. So this is why we have seen in the primary circuit that if a DC is fed to the primary circuit through this circuit of MOSFETs and LC oscillators and body diodes and resistors, this will produce an AC current, that means an AC field at this primary circuit. According to Faraday's law of electromagnetic induction, whenever there is a changing flux, it will induce a current in the secondary coil by the law of mutual induction. So due to that, in this secondary coil, due to this mutual induction in the secondary coil, a AC current is being induced. That AC current will flow through this circuit known as the full bridge rectifier. What does this full bridge rectifier does means, I will explain you one thing. Assume that your AC supply is in this type, then what does this full bridge rectifier does means, it will convert like this. That means it will convert a DC to an pulsating AC. it will convert all the negative half cycles into positive half cycles. This is the role of the full bridge rectifier. Then if we see here, we are having a capacitive filter. A capacitor of 100 nanofarad value is used as a capacitive filter. What does this capacitive filter uses means? Here also if you see, since this is a DC having no change in direction, but there are certain pulses. So what it will do means it will remove those pulses and give a clear DC. So why do we need a clear DC means we are feeding it to the resistor. Resistor here means our electric vehicle. So even there, if there is a small fluctuating DC is there, it will cause jerks in the motion of the electric vehicle. So it will be a big problem for the vehicle. So that why a capacitive filter is used, so that we get a pure DC form, so the electric vehicle can move without any jerks. So if we see the total thing that is been related here is that if we are feeding a DC, we are converting it to a high frequency AC, and then it is passed through a 4-bridge rectifier. After passing through mutual induction link, then it will get converted into pure DC by capacitive filter, and it is the power through which it will be utilized by this electric vehicle to go on. So this running of the electric vehicle will be explained to you in the demonstration. Now I want to show you the another part of the circuit, which is nothing but the Arduino switching circuit that we have used. This circuit is used to solve a certain problem in our circuit actually. So if we see here, this is the primary circuit. This has to be connected to each and every coil that is placed on the road. So if you have a numerous of coils, we need to create these kind of circuits in a very numerous number. So which will be very cost efficient and will be a very drawback of this project. So we have thought to make that this circuit will be fed to coil whenever the car is on that specific coil. So for that purpose, we have firstly used the IR sensor, infrared ray sensors. Whenever the car is before it, it will send a signal to the Arduino that car is before me. Then this Arduino will switch on the relays through the relay switch through the primary circuit to that specific coil, so that specific coil will only be producing the alternating flux, so that the car will receive power from that coil and it will move forward. After it came here, this will sense and will give the signal to the Arduino board, and this Arduino board will send signal to relay switch to switch on the coil of that specific sensor. So thus the switching between the coils happens, and same only a single primary circuit is fed through numerous of primary coils that are in the road. So thus this electromagnetic vehicle, MIV, magnetic induction vehicle circuit works. And thank you.
I am here from BTech first year electrical department. I am here to demonstrate our project.
Hi, I am Praneeth. I am from Electrical 2021 BTech.
So this is our power supply. This is giving our 12 volt DC supply to our circuit. This is our circuit. This is an AC/DC converter, which is using some MOSFETs and capacitors and inductors. These capacitors and inductors are giving some LC oscillations, which are using as in starters for the MOSFET, and which is converting DC to AC high frequency. So from this circuit, we are having two supplies. One is a common terminal to our coils, which are like these. These are co-spiral coils which are embedded under the ground, and there are several coils which are embedded one by one under the ground, and these are having a common terminal which is connected to this circuit, and from this circuit we are having another terminal which is connected to our control box and IR sensor.
So this is the relay and this is the Arduino. So let me show you how the sensors work. And this is the, like, we have put this to the car because this acts like an antenna, like it between the sensors, like this helps us in detecting the motion of the car for the sensors. So let me show you how. See, there are like 4 bulbs in this. When one glows, like it shows in which coil the current is there. Right now it's in the first coil, so second coil. So let me show you. Wait. See, now it's in the first coil. When the car reaches the first sensor, it shifts to the second coil. The current shifts to the second coil. So now the car gets power from the second coil. And when the car moves to the third sensor, you can see the shifting, like the current gets to the third coil. And now again when it moves to the third sensor, the current gets to the fourth coil. And this is how it works, and this gives the car continuous power and car moves like this.
So let's give you the demonstration actual working of our project. See, I have switched on the voltage which is coming to this side. See here, the first bulb is glowing, that means our current is in our first coil. So let me show you. See, the vehicle is being run. Show you. See, what is happening that the current is being switched from one coil to another with the help of this. See, when it will be here, it is in first coil, it is going there, it is being converted to second coil, after here it is on third coil, and after that and so on. We will place multiple coils under the ground, and due to which our vehicle will have a continuous flow. Let's see it again. See, this is the actual demonstration of our project. So this will lead to our a good future. This is a good future plan. So that's all about our project. That's our demonstration. Thank you.
This was the project learn in the way of making it, and as my friend explained, I will please explain you the problem we are trying to solve with this model. Basically, this model is based on Lane law and Michael's Rider law of electromagnetic induction. And we saw how the electromagnetic induction takes place in primary coil to the secondary coil, which help us to be clear in the car we are using. And we are also using circuit which mainly includes MOSFET, capacitor, resistor, diode, etc. As my friend Revanth beautifully explained and why we use it. And we tested this model many times, and during this we faced difficulty, which we hold as a whole team. We solved it, and as you can see in the demonstration for how it works, and how the Praneeth and Rajan explained with the working principle, how it works. And at last, this model is based on MIV principle, and this model is one of the example of MI project, and we can implement this MI project in different places, like we can deploy trucks, normal trucks in EV and we can also use this to goods transport in big malls and warehouses. Thank you.
I want to acknowledge all the persons who guide us, who help us in this model. I want to thank Mr. Manoj Pandey sir, our instructor to the technology of Fusion G11 course. And I want to give a special thanks to Mr. Dilbagh Singh sir, who guide us in this whole project and help a lot. So I want to welcome all the members and Mr. Dilbagh sir.
Thank you.